Let's talk about some terminology. We said this phrase, improper integral. What does it mean for an integral to be improper? Again, one version is that the interval you're integrating over is unbounded. In other words, you're integrating from 1 to infinity, or negative infinity to 0, or even negative infinity to positive infinity. So the limits of integration involving some sort of infinity is going to be one type of improper integral. Now, what you'll see here is to calculate an improper integral, we write it as a proper integral, but taking the limit of it, just like we did in the preview activity. So we use the first fundamental theorem of calculus to calculate this integral. And then once we're done with that, we calculate the limit and see if it exists. If that limit exists, we're going to have an unbounded region that has a finite area, which is kind of crazy, but it does happen. If this limit doesn't end up existing, or if that limit is infinity, then the unbounded region has unbounded area. Let's explore this through another activity. These are going to be some integrals that are going to be extremely important for us to understand for future things we're going to be working with. Okay? And the two examples are integral from 1 to infinity of 1 over x dx and integral from 1 to infinity of 1 over x to the 3 halves dx. Okay, so in this activity, you're going to, once I go through it a little bit with you to help you get started, you're going to pause the video and you're going to work on it yourself. Leaving aside this improper integral, we want to start by calculating some integrals that are more familiar. We should know by now what the antiderivative of 1 over x is. You're going to get a decimal approximation of each answer. Then you're going to, instead of having this upper limit of integration be a number, you're going to have it be the letter b. When you calculate this integral, you should end up with an expression that involves b. Then you're going to take the limit as b goes to infinity. You're going to do the same thing for part b, which is going to involve the integral from 1 to infinity of 1 over x to the 3 halves dx. Same kind of thing. Try some numbers, then b, then take the limit. And you should definitely think about what you notice happening here. Is there a pattern arising? This pattern is going to be super important. You next have the integrands themselves that you can look at as functions, because remember, what do these integrals represent? They represent area under these curves. So you're going to try to decide what kind of pattern of behavior you're seeing with these integrals, these unbounded regions under a curve. Do they have finite area? Does one of them have infinite area? The other one doesn't? Do they both have infinite area? Is there some sort of pattern? That's what you're looking for.